Hello dear friends and welcome to another electronics tutorial. Today we're going to discuss diodes. So let's start with the function of a diode. Why do we have diodes in electrical circuits? So diodes work as a one-way function. As is described in this picture here, you can see there's a power supply, a battery, whatever, and the diode as an arrow conducts the current from this power supply to this lamp here. If we supply or replace the diode with the cathode on this side and the other anode on the other side, the lamp is off. So this means that the diode is blocking, is not conducting. In this case, the diode is conducting from plus, the current goes through the diode from the anode to the cathode to turning the lamp on. On the other side, it's in a blocking state where the power just doesn't, the diode blocks the flow of current here, so only very few microamps will pass through the diode. As a electrical schematic symbol, the diode is an arrow marking the anode and the cathode. And here you can see some very common diodes that you will most likely encounter in different electronic circuits. So the first diode that I also used is the 1N4148. So this is the most common type of diode that I've used. You can see here the cathode is marked with a black part at the end of it. Also, you can see all the diodes according to the cathode. There, all the cathodes are marked. And also, another very important diode, if you want to build an electrical circuit, is the 1N4007. Going forward to a bit more details regarding the parameters for a diode. So when you want to use a diode, there are a couple of parameters you need to watch. I've marked here with light blue a couple of the most important ones. First of all, the maximum repeat peak reverse voltage. So as we discussed, the 1N4007, this has a 1000 volt reverse voltage. So this means that in this case here, I can have a maximum 1000 volt power supply. I would not recommend 1000 volts. I would recommend maybe not going above 800 just for keeping safe. But the rated supply from the manufacturer is 100 volts, 1000 volts, and also the conducting current, so the maximum average forward rectifying current. So this means the current going when the diode is conducting. So this means that this diode can drive up to 1 amp through it and light the lamp on. And also very important, when a diode conducts 1 amp of current, it will have a forward voltage. I mean, there would be a voltage level that would appear from the plus to the minus side of the diode. This would be the forward voltage for the diode and um, would represent the junction voltage drop for the diode. So when it is conducting, it would have 0.7 volts. When it's blocking, it would have the supply voltage in this case. On one side, it's, let's say, 0.7, or in the case of 1N4007, it's 1.1 volts. And on the other side, when you're measuring the voltage drop from the cathode to the anode, it's going to be the voltage for the supply. Going forward, for regarding some types of diodes, there are multiple types of diodes because, as I said, they are widely used in electronics. Um, the most common, or the junction diode, the 1N4007 that we've been discussing, it looks like this. They mainly are used as rectification or one-way switch. So either they are just conducting current, so just conducting current from one side to another, or they are just blocking current going from the cathode to the anode. Here you can see a very simple graph how this works. So when the diode is conducting, you can see that the current slightly grows as the voltage on the diode grows from the anode to the cathode. And at zero point 0.7, or in the case of 1 and 4007, 1.1 volts, the diode will start conducting, and here you can see the current just grows up, and the voltage drop doesn't increase that much, but the current just goes up. So this means that here it's open state, and till here it's in a block state or not conducting state. Another very important diode that it's quite used is the Schottky diode. So the Schottky diode, I'm just going to zoom in a bit here, has a very particular design. So diodes usually are a P-N junction. So they are a junction between a P substrate, silicon substrate, to an N-type substrate. The Schottky diode has this metal part here, and the junction is very, very small here to the N-type junction. So it's a metal to N-type substrate here. So this means that it will have much lower conductive state. So usually, as we discussed previously here, we are conducting at 0.7 volts on a diode, and for the other diode, we're conducting at 1.1. In case of a Schottky diode, here you can conduct at zero point 0.5, it's about 0.55 volts, and even as low as, I think here it's about 0.2 here, so around 0.25, maybe from 0.2 to 0.3 volts. So this means that it opens much faster. So um, for high speed application, you would be using a Schottky diode because it has very fast recovery rate. Other diodes which are quite important, and I would like us to go through, are photodiodes. So photodiodes are diodes that are influenced by the light around it. So in case you have a photodiode, of course there are multiple types of photodiode, but there are some, for example, in the uh, emitter and in the receiver from example from a TV. So in the emitter from the TV, you have this diode here. This is emitting. You can see the arrows are going out, and this is emitting, for example, infrared signal. And then the photodiode on the TV, this translates this infrared to a different voltage drop on it, or it allows to pass a very small amount of current from the cathode to the anode. So these are the photodiodes are used as light sensing um, features for transmitting different messages. So from with this infrared LED, for example, from the TV remote, you can send like a coded digital message for the button that you are pressing, and the photodiode on the TV is the one that is receiving this message. You see that the arrows are pointing down, and then the TV, and with this voltage level between the cathode and the anode, the TV can translate this in a digital signal and then say, okay, I have to switch to channel 12, for example. Okay, going forward, because there are a bit more diodes here, very important, the Zener diode. Zener diode are used to supply constant voltage. These are one of the, let's say, the most important components in some of the power supplies. The idea for a Zener diode is that, as we've discussed, the diode conducting here opens at 0 0.7, 1.1, depending on the diode. The Zener diode, when it's placed in this way, so it's supplied, it's reverse supplied. I mean, the supply is on the cathode to the anode. It allows current to flow through it only if the voltage exceeds a certain limit. So, for example, you would see a lot of Zener diodes that are 5 volts, for example, and this diode would act the following way. When you're supplying this from the cathode to the anode, let's say you have a power supply here. When you reach with this power supply the 5-volt limit, it will start to open here and will allow current to flow through it. When you are going below 5 volts, it will automatically shut down until if you supply it on the other side, you will have the 0 0.7 volts for the forward current. So as is written here, so you have a reverse voltage and a uh, forward current. This is kind of creating a stable voltage level for this for the output of the Zener diode. We will discuss the Zener diode more in detail in the simulation part of the video. Another important and vital part of the diode family are the TVS diode, or the suppression diodes. These are very these are usually for protection of the circuit. So as a structure, they are very similar to the Zener diode, because they when the voltage reaches a certain threshold, this diode opens and the current is drawn by the diode, and it doesn't affect the rest of the circuit. You can see it here. So the voltage rises, and when it exceeds the TVS diodes designed limiting voltage, it will automatically short it to ground. And you can see this is the input waveform where you have a very high spike, and this is the clamped value. So you can see the same spike, but the clamp, I mean the top side, the high voltage here will be totally cut off, and then would protect the load. This is very important for example, for automotive or aerospace designs, where you have to somehow protect in case something happens and you have an over voltage. Maybe another equipment inside the car has a malfunction, and it's sending on the supply line, on the battery line, it's sending a very high voltage spike. This then has to be clamped somehow, limited, that it doesn't destroy the whole car here. Okay, going forward, the last type of diodes that I would be discussing today are the LEDs. The LEDs function quite simple, so they have a long lead. So the surface mount one have a long lead and a short lead. You can see that here you supply it. It goes to the anode, and then from the other side it goes to the cathode. Also, LEDs have also the cut side here so that you know where the cathode is. On all LEDs, there is some kind of marking for the cathode, including for the Zener, except for a bidirectional TVS, which, yeah, it sometimes doesn't have a marking here. But most of them have the cathode marked. Regarding the LEDs, one thing I would like to mention, so there are different voltage levels for the LEDs. So, for example, for infrared, the diode opens at about 1.7. It opens even at 1 volt. Here it's starting to open, and then it rises. Then you have the uh, RGB spectrum, and then you have at kind of at 3 volts you start the UV range. So for example, if we're discussing about infrared LED, then you will have very small voltage. 1.5 volts here would be the like a good opening voltage for it, and you will get like 50 milliamps, which I think is much more than you would need for example, for a remote control for a TV. Yeah, so this would be the infrared, RGB, and then UV spectrum, and also the voltages for these types of LED here. In the next section, we will be discussing a bit, doing a small simulation in Tinkercad about diodes. We will go a bit into more detail. We'll run some simulation. Okay, so now we've opened tinkercad.com through the browser, and let's start by creating a new circuit. If you're not quite familiar with Tinkercad, so here is the workplace, the bench where we're actually building the circuit. On the right side, you will see a lot of components, and here is the start simulation button, which is required for us to start a simulation for the bench. So first of all, I would like to get all the components, and let's start with a diode. Let's start with a diode here. So let's place a diode and a power supply to see how this diode is working. So the power supply is here. And also let's place something that will show us that the diode is working, like a light bulb that would light up if the current is flowing through the diode. Let me rotate a bit this diode. You can use the R key on your keyboard to rotate the diode. Okay, so first of all, we are going to supply it positive. So here the positive line goes into the anode of the diode and then continues through the cathode to one of the terminals from the bulb, and then from the second terminal we have to connect this to ground. Okay, let's see, first of all, let's see what is the supply voltage. So the power supply is set at 5 volts. Let's put it to 10 volts, just that we get a bit more light from the light bulb here. So let's start the simulation. And the light bulb turns on at 194 milliamps. That is great. That is great, great. Okay, let's do the same simulation, but let's place the diode in reverse polarity. Let's put it exactly on the other side. So we are placing a power supply, we're setting it to 10 volts. We are taking a diode, rotating it to put it in place, and then we're going to take a light bulb and place it here. Great. Now all we have to do is run the wire from one terminal to the, oh, this is placed also, so I have to rotate it and put it in blocked position. So from the cathode, we go to the positive terminal of the power supply. From the negative, we go to the light bulb. And from the negative on this side, we just connect this to the other pin of the light bulb. Okay, let me tidy up this a bit and maybe do a bit more better. Yeah. Okay, now when we start the simulation, we see this this light bulb turns on at 194 milliamps, and this is not turned on because the diode is blocking the circuit from working. Great. So this was the simple diode, rectifying diode that we have discussed today. Another type of diode, we have the Zener diode. So for the Zener diode, let me create another circuit here. What we want to do is repeat the same process. Put a power supply here, set it to 10 volts, and then for the Zener diode, what we want to see is that this diode holds the voltage, because remember, this is a rectifying diode. We want this diode to have a fixed voltage. So if we want to do this, we would need a resistor just to limit the value on this diode. Let me put a 1 kilo ohm resistor is quite well. Let me place this here, and we want to measure this value for voltage. So I'm going to go and take a multimeter here, just that we measure the voltage. So connecting resistor to the plus, the positive of the power supply, terminal 2 connected to the cathode of the diode, and then also we have to connect the multimeter. We can connect the positive to the cathode here, and the negative to the anode of the diode. Okay, please remember that in case of a simple diode, as we did before, in this case, this would not conduct. You know, it the power supply in this case, this is a simple diode. You know, it will supply the resistor, and here would see very high impedance would block the diode, and then it would not supply anything else on the other side. Okay, let's see how this works. So we start the simulation. We are drawing about 4.56 milliamps. Great. And we see a 5.44 volts. This is let's put a 5-volt line here. Maybe increase this resistance a bit more because it's quite, yeah, it's quite small. Maybe even more, 10 kilo, because it's drawing a lot of current. So we are at 5 volts. Great. Let's do a 3-volt power supply. Let's assume that we need a 3-volt line here. Let me stop the simulation, and we're going to take another Zener diode, rotate it into place so that it's reverse polarized. I repeat this again. Control C, Control V for the resistor so that we don't change the values again. Put the um, resistor connected to the power supply. Great. Okay. Connect the anode to the power supply. Great. We need another multimeter because we want to see both of them work together. So I'm going to take the negative and connect it to the anode, and then we're going to take the positive and connect it to the cathode. Great, great, great. So this is also showing 5.11. So we want to output, so we want 5 volts on this side and we want 3 volts on this side. So let's place here a 3 volt Zener diode. So now we can create any type of power supplies, any type of voltage levels, as long as they are below 10 volts and of course higher than the and higher than 0, and the Zener diode, if we're going to use Zener diodes, they will provide us the output values. If we want, for example, to do 7 volt, um, if we want to do a 7 volt power supply, we can do quite easy. So it's going to be just the same. We just copy the components and then, ah, okay, we just place them below. We put a zener for, let's say, 7 volts, and then we just connect these together, and then you have a 7 volt output line where that you can use in your circuit, and it's quite stable. There is a rule of thumb for the Zener diodes that you want to have a bit of current running through them because they can get a bit noisy from time to time. So that's a good rule of thumb to have at least a couple of milliamps going through the Zener diode. Okay, and now I'm just going to straighten this up, put this at 7 volts, and perfect. We have a 3 volt voltage source, 5 volt, 7 volts. Great. Next step would be to discuss a bit about photodiodes. So photodiodes are another type of diodes that are quite used in electronics. For this, we're going to take a power supply again, supply it at 10 volts. It's already set. And what we are going to do is we are going to add a resistor in series to the power supply, and then we are going to measure the voltage on this photodiode. So let's connect this to the power supply. This is a 1 kilo. We would need a bit more resistance. And then we connect the photodiode, and then we connect the multimeter. The multimeter allows us to measure the values of voltage on the diode, because these photodiodes are quite useful if you want to measure external lights. For example, these garden lights have types of photodiodes inside. And then let's start the simulation. Okay, so now the photodiode is at 9 volts. It is um, it is positive, so it's conducting from the cathode to the anode. So it's placed as is the Zener diode reversed. And when we start this, you can see that when it's full light outside, it's 0 volts, and as the light is diminished, you can see and you can measure these values. This is very important because you can measure, okay, now it's getting a bit dark. Now, for example, you can turn on the sprinkler system or anything like that. Okay, so this is a photodiode. You can see you can play with it, get different output voltage levels here, depending on the external light. Okay, And the last but not least is the LED. The LED is quite simple. For the LED, what is quite important, because here there are multiple colors, we can create multiple, we can see multiple voltage drops. So let's take a red LED and see the I've mirrored. You can mirror with the M key. Let me add another power supply and let's see different voltage drops for different LEDs. Just that we can have an overview how these LEDs are working. Let me rotate this a bit so that we can add a multimeter on the right side. Okay, and connecting one terminal here, and the cathode we connect it to the power supply, and then this, oh, 100 kilo, it's too much. Let's put like 200 ohms here, would be more than enough. And then let's go and create multiple. Let's put like 5 LEDs here, and then the second one, and maybe put all of them, and then we can change each of them to see how they are to different colors. So this one is red, we can put a blue one, we can put an orange one, we can put a yellow, and of course a green LED. Great. Now let's connect them. Okay, and everything goes to the supply. Everything goes to the supply, connecting them to the supply, and connecting them to the supply. I think it would have been easier if I would have used a breadboard. The software also has this type of breadboard that you can use for creating this connection. And now we're connecting the grounds together. So I'm just gonna pull from here. And now the multimeter. What are we going to measure? Voltage drop. We want to see the voltage drop for different LEDs, so that we can get a sense on 2, 3, 4, and 5. Let me order them a bit. So first LED, I'm going to just drag and drop them. Negative to the cathode. It did not connect here to the positive to the anode. Negative to the cathode. Let me zoom in a bit. Positive to the anode. Negative to the cathode. And positive to the LED anode. It's somewhere here. Yes. And again, negative to the cathode and positive to the anode. Okay, great. And now let's start the simulation. All the LEDs are pointing at 2.3 volts. I think this is a standard LED for here. They don't have different voltage levels. In reality, these LEDs would have different voltage levels on them. Um, Maybe if I decrease a bit the resistance for some, no, this is also exceeding, so 200 ohms, it was a good resistance here. Yeah, so the software is saying that all the LEDs would have the same voltage drop. In reality, they would have different voltage drops according to our to this graph here. The red should have a smaller voltage drop, the green, the orange, everything would have a different voltage drop. Okay, with that being said, I would like to thank everybody for their time for this tutorial. Hope you have learned something new today and wish everybody a great day. Let's keep in touch for new tutorials.